So what is the meaning of the hydrophobicity? So if your hydrophobicity, when we have a drug and it's hydrophobic one, so it's easier for them to dissolve in an organic solvation like octanol, and so we need some drugs that they can be dissolved in the water, so they should be a little bit polar, and also they have to be dissolved in the cell membrane. So hydrophobic, they should be hydrophobic. I'm just explaining some of the example of the hydrophobic, and also they can be dissolved in the water. So octanol, or any kind of alcohol, but some fatty acids, they have one part of them they can be soluble inside the organic solvent, and one part they can be dissolved in the water. So both of them can be dissolved in an organic or water. So first I just want to show you the organization of the cell membrane. So cell membrane has some units of they have some heads that they are hydrophilic, like phosphate, and some part they are hydrophobic. So as you can see, fluoxetine, atenolol, morphine, paracetamol, ibuprofen, they have some part of the hydrophilic. For example, nitrogen with lone pair, oxygen with lone pair, fluor with lone pair. These are polar, and they are the part of the molecule that they are polar, and they can be dissolved in water. Also, some rings of carbon, they are so hydrophobic. So why fluor and nitrogen and oxygen, they are polar? Because they have they have high electronegativity, so that their nucleus, they can attract because of their electronegativity, they can attract the hydrogen electron cloud, and they can still and pull all the electron cloud from the carbon, and they pull it to they can pull it to their self. So that's why they are that's the way they works as a polar. So in atenolol as well, you have a ring that is really hydrophobic, and water hydrophilic, because of the lone pair and because of the attraction of the electrons. So some of our drugs, they should have two parts: one hydrophobic and hydrophilic. What is the meaning of P? P means partition coefficient. That means that if we put a kind of drug into a container that has two parts of solution, one of them it's hydrophobic, and the other part is hydrophilic. How many of these molecules they will dissolve into the hydrophobic solvent, and how many of them they will dissolve in hydrophilic solvent? So for this reason, we will make a solution. So in yellow part, that which is hydrophobic, we have octanol. So what do the molecules of octanol look like? They have hydrophobic part and hydrophilic part, and octanol is alcohol functional group, and water, that is so hydrophilic, and in here is hydrophilic. We will put some of our drug in here, and then we will calculate that the concentration of this molecule of our drugs in both area. If your drug can dissolve into your organic more than dissolving into the water, it it says that it's just telling that it also can be dissolved in the cell membrane. And as I explained, that what is the molecule of the membrane. So if the drugs molecule are similar to our membrane, they can be dissolved into each other. So this drug, they can pass through the membrane. So if a drug is really dissolvable in an organic or hydrophobic, plastics, they are hydrophobic or lipophilic. So as you can see, I just written one polymer of plastic polymer, so it's polystyrene. So polystyrene, they have a lot of carbons without any electronegativity atoms like nitrogen or oxygen or fluor or chlor. So we don't have any of them. So polystyrene's polymer is so lipophilic. So this drug, the drug that is hydrophobic, they can be dissolved into the plastics. So some of our packaging, so drug packages, you can see some of them, they are made of plastic, so they can be dissolved into our packaging. Partition coefficient or P, it depends on the lipophilic characters of a substance. So are they hydrophobic or are they hydrophilic? If they are hydrophobic, if they are lipophilic, or they love fats, so they can dissolve into your octanol. What else has effects on the increasing of denominator in this ratio? If it's a polar one, so this ratio will decreases, because the more polar molecules, they just want to be dissolved into the water rather than the lipophilic molecules. Size of the molecule is important and shape of the molecule important. The value of P depends on the temperature. So you know that if you have a lot of if you warm the solution, most of the molecules, they can many of them, they can be dissolved better and easier. The amount of solute and solvent doesn't affect on these two ratio. Why? Because these two ratio are concentration. Even if I put 1 kilogram or 10 gram of a container that has octanol and water, just only, for example, 10, some of them, they will go into your lipophilic part, and some of them hydrophilic part. So it doesn't affect on the amount of that, because it's a concentration, it's not amount of that. Between these three medication, barbital, phenobarbital, and secobarbital, secobarbital is more lipophilic, so they can be dissolved into octanol rather than the water one. So the concentration is higher in octanol, is more than water. So the p-value will increases. So concentration of secobarbital is more than the concentration of secobarbital in the water. So concentration is important, concentration, not amount of that. So if if this medication can be dissolved into an organic solvent, it means that it can be dissolved into the colon's cell membranes. So many of them, they can be dissolved through colon. Anesthetic medication, they will affect on your brain, so on your neurons or spinal cord or brain. So most of the cells inside our brain are made of neurons. So neurons have thousands of layers of membrane. So Schwann cells, they just wrapping 1,000 times wrapping the neurons or axons. So 100 layer of the membranes, they cover axons. So membrane is so lipophilic, so your drug should be really lipophilic. So most of the anesthetic medication, they have to be dissolved into your octanol, and 100% should be dissolved in here, and none of them they dissolve into the water. So that's why the P is 100, or 100 times the concentration should be 100 times. If its concentration is 1,000, so the dissolving should be, for example, 10. So 100 times should be more. Should be dissolved in a it should be really lipophilic. Now your medication, this is your medication. So your medication will be dissolved into your organic solvent in here, and also it can be dissolved into water. Yeah, if this molecule is has some functional group like COH, or something that can be dissociate, so like giving ionized can be ionized, so in water, so your molecule will be dissociate into the water as well. So some of them, they are whole molecules, some of them they are ionized. So if we change these, if we change pH here, changing the pH of this water, if we change it, so we can shift this medication. If it's if we put some protons, so we shift the ionized one to non-ionized, and if we increase the pH, or make it a little bit, or if you make it a little bit basic, so this molecule can be dissociate to produce more hydrogen to neutralize these hydroxide. So with changing pH, we can change the ratio of these. With changing pH, we can change the ionized molecule. So if, for example, we add some basic solvent or solution, so we will get some more, we will dissociate more whole molecules, they will dissociate and produce ionize to neutralize OH. So we will have the concentration of A minus increases. If we take some of these molecules from here, so some of the molecules, they will come to the water from the octanol. So still the concentration capacity of this part and this part are the same. So the concentration, still some of the solid can come to the organic solvent, and some of them, they can go to the water. So the concentration of the whole molecule or non-ionized are the same in both of these solvents, but the amount of the ionized molecule is increases. So this part of the pack is just explaining this. Again, in this part of the pack, I'm just explaining. It says that a weak acid, a molecule that is a weak acid. So this is a weak acid. This weak acid is as the pH falls, so your pH falls, so it means that you have more protons in your solution. Which solution? This solution, this one. So your acid, your weak acid will is not going to be ionized and doesn't give more protons. So they prefer this drug prefer to be HA and a whole molecule, unionized molecule. So if it's unionized molecules, so because the capacity of the water is not going to be changed, so it cannot accept more molecules. So they prefer these molecules, the whole molecules, they prefer to go back to octanols. So octanols, that's an organic solvent. So the ratio of the concentration of medication will increase. So as you can see that the concentration of logD will increases because the denominator will increases. So that's why this amount will it's the highest level. As we decrease the pH, increase the pH, what will happen? So when we have less hydrogen ions, so excuse me. So D or log D, it doesn't matter if it's D or log D. Whole molecule will increases, and most of them are in your organic part, and this amount doesn't change because the water just has the capacity to accepting just amount of specific amount of these drug. So if we get more whole molecules, they shift it to the organic part, so the ratio in denominator will increases, so D will increases. So as you can see that in higher pH we have when the pH is high, so the log P is high as well. But when we decrease number of the hydrogen ion, when we decrease the hydrogen ions, or when we increase the number of the pH, for example in 6 or 7 or 8, means that we have lower hydrogen ions in here. So in a lower pH, now your weak acids tries to make more ionized molecules to produce more hydrogen ion. So this dissociate more. It dissociate more. So most of them, they will go. So most of these ionized molecule, they will shift to the ionized one, and we have less non-ionized here. So from our organic part we will get some whole molecules, because we've lost some of our molecules. We lost some of them because we wanted to make more ionized molecules, so we need some unionized, because we have the capacity to getting more full whole molecule. So from our octanol we will give back some whole molecules from our octanol. We will go back to the water. So in this case the ratio in here will decreases. Although the concentration of here was the same as before, but the denominator will decreases. So log D will decreases as we increase the pH. Weakly acid will absorb preferentially. They want to be absorbed through the stomach. So acidic molecules, they love to be absorbed through stomach. In our stomach we have low pH and more hydrogen ions, because this weakly acid is not going to be dissociated into the stomach. But if you put your weakly acid in somewhere is basic or with less hydrogen ions, so this weakly acid will tries to produce more hydrogen ions. It means that it dissociates and get ionized more. So if it gets ionized, it's harder for them to be absorbed through an organic solution such as membrane. In weakly basic drugs, they love to be absorbed through the intestine. Why? Because in our intestine the pH is high, and it's intestine environment. Inside the intestine environment we have a basic environment, and also we have less hydrogen ion. So your base doesn't want to give some more hydroxide ion for neutralizing the acids, hydrogen ions, because in our intestine is not really acidic. So less acidic, it has less hydrogen ion. So in our intestine, most of the basic molecules, they are whole molecules. They are not ionized, they are unionized. So if we have more whole molecule unionized, they prefer to go if we have more whole molecules in here, so, and the capacity of the water in the intestine is just constant, it doesn't going to be changed. So some of the extra whole molecules, they will go back to the octanol. Octanol means that, for example, the membrane. So some of them, they will be shift to the membrane. So to just keep this concentration of whole molecule into this water, make it constant most of the time. So because the capacity of the water is not going to be changed, most of them, they are whole molecules, they will go back to octanols and then they will be absorbed. So absorption will increases. The formula or equation of log P can be written as this sentences, and also it can be written as like this one and this one. So sometimes maybe, but I haven't seen kind of this question, but sometimes they will give you pKa, they will give you pH, they will give you all these concentrations, and you will get a log from all of them, and then you will calculate the log P. Sometimes they will give you these two values, and they will ask you about log P. So don't worry about this. Don't worry about these equation. This diagram is a little bit scary, but don't worry, I will explain it. Imagine you have a really weak acid into your gut, into your it doesn't matter if it's in your stomach or if it's in your intestine. So I imagine that it's in your intestine, it's not in your stomach. So the pH of this environment is 6, for example. So your molecule can be your whole acid molecule wants to just dissociate. Some of them, they will dissociate and then produce ionize. Some of them, they don't ionize. So some of them, they don't ionize, some of them, they ionize. So between the ionized and non-ionized inside your intestine, there is an equilibrium. So you have a concentration here of a concentration of unionized, and you have a concentration of non-ionized here. Unionized molecules, they are they love to be dissolved into membrane because they are not too much polar, so they can pass through your membrane. When they reach to your membrane, pass through to your membrane, for example, if you have, imagine 10 molecules of unionized in here, and I don't know, any number, 5 number of unionized into your in your intestine. You have 10 molecules in here. So if you have 10 molecules in here, so you will have 10 whole molecule in here. So if you shift these molecules to your blood, so what will happen? Some of these molecules, some of these ionized ones, they gather together to make a new ionized molecule to fill this compensation, like a compensating the loss of the unionized one. So still we have these 10 unionized molecules because this sign means that equilibrium. So if you have something, we lost something here, so you will get it from somewhere, if the ionized one. So now your whole molecules are here into your blood. So we have another equilibrium between the ionized and non-ionized or unionized to ionized one. So it increasing the number of the ionized molecules depends on the pH of the new environment. So in this case we have some basic, in compared to the intestine, in compared to the intestine we have more. So pH of here is different from here. So this equilibrium in your blood is different from your equilibrium in your intestine, but the concentration of whole molecule in this intestine and the amount concentration of the unionized or whole molecule inside to the blood are the same, because there is an equilibrium between them. So now, because in our blood is more basic rather than our intestine, so some of these molecules, they will dissociate to produce some ionized molecule. So this ionized molecule, they will increase the concentration of the ionized molecule. So the only things that we have to know that the concentration of these two unionized molecules are the same, and the concentration of the ionized in the intestine, ionized in the blood, are depend on our pH, on the pH of the environment.